Everyone, welcome to my channel. In today's video we are going to talk about microservices circuit breaker pattern, like what is the use of this pattern, why we need it, and what are the advantages of it. So before I dive into circuit breaker pattern, let's see what is the problem that we are trying to solve here. So let me give you a simple example. So let's imagine that you have two services. Let's call this service A and the other one is called a service B. Now service A here, if you think of it, let's call it the client. Let this be the server. So service A makes API calls to service B, and usually if we assume that, let's assume that the latency is 100 milliseconds for service B to respond. So it keeps making hundreds of calls to service B. So as long as service B is faster, so service A works just fine because it keeps getting back response in 100 milliseconds. So now let's assume that at this point service B has slowed down for some reason, right? So once service B has slowed down, now the calls to service A, so for every call you would set a connection timeout and a read timeout, right? So as service B slows down, if we assume that all these calls are taking up now 5 seconds instead of 100 milliseconds. So it keeps making hundreds of calls to service B and all these calls are taking up 5 seconds. So now what would happen? On client A, we have a limited number of, if we assume that service A is on Tomcat, so you'd have a minimum number of, like a maximum number of threads set up, right? If you're on a SpringBoot application, you have, like, I think by default you have 200 threads, Tomcat threads that are set up for the service A. Now if all these threads are taking up like 5 seconds, then what would happen is you're running out of these threads. So as you run out of these threads, what would happen is service A will start to slow down. Now once service A starts to slow down, if you imagine a third service here called service C, now all the calls going out to service A will be slower, and as a result service C starts to slow down. So as you can see, this is a cascading effect. If one service slows down, it will take down all the other upstream clients as well. So this is the problem that we are trying to solve right now. So now let's see what would happen if we have a circuit breaker in place. Now again, the same design, right? We have same two services, service A and service B. Service A keeps making calls to service B, and each call is taking like 100 milliseconds. Now at this point service A has slowed down, right? But now we have a circuit breaker. We have a circuit breaker in service A. We have circuit breaker installed in service A. Now what would happen is calls would start to it will start to slow down here. It will take 5 seconds. It would make another call 5 seconds. Now circuit breaker will kick in here because it identifies that calls have slowed down or they started throwing some exceptions. Now what at this point circuit will go to an open state. Circuit will go to open state. So what does this mean? Once the circuit becomes open, then it won't send any more calls to service B. Rather it would start to like fail fast here. So it will fail fast for any calls. It would start to fail fast, and after a couple of seconds it would send another test. It would allow some of the calls to go to service B. If this call still fail with the same exception, service will remain in the open state. But if the calls succeed, and then if they don't get back this exception, then the circuit will become closed and it will let all the calls flow through to service B. So in this case, if service B is slowed down, since the circuit is going to open state and since it is failing fast, the 200 threads, if we imagine that this is the Tomcat threads that we have set up on service A, these threads, they will not be logged. So as we are failing fast, we still have threads available for use. So service A will not slow down. So that is the main advantage here. Yes, of course, it will start to throw exceptions when it is failing fast because it's not calling service B, but service A will not get slowed down. As a result, if there is another service C which is calling service A, even that won't get slowed down. So you're preventing this cascading effect. So this is how a circuit breaker pattern will work. So you would define the condition saying if out of the 10 requests, if let's say 50% of the requests are failing with some sort of an exception, you would want the circuit to go into open state. And once in open state, it would start sending, it would go to a half open state, at which point it would start sending maybe 1 or 2 requests to service. It would allow 1 or 2 requests to go to service B, and depending on the outcome, it would either go into a closed state or it would still continue to be in the open state. So this is how a circuit breaker pattern works. Now let's go back to our slides. So why do we need circuit breaker, right? So this is for graceful degradation when a service call fails. As you can recall from our example, when service B fails, we don't want to take the whole fleet down, rather we want to gracefully degrade. Prevents from cascading failures, right? So as you stop sending, allows the failing service to recover. So what does this mean? In our case, if we have service A and service B, so if service B is under heavy load, and if we still keep sending requests to service B, it cannot really recover. Rather, if we start to fail fast and stop sending load to B, we are giving it some sort of a chance to recover quickly. And similarly, allow the upstream clients to fail fast, and this is, we have already discussed about it. So these are the advantages of having a circuit breaker. Now, which libraries provide this circuit breaker functionality? So the most popular ones is Hystrix. So Netflix developed this, but I think they stopped supporting this library. So some of the other popular alternatives are Resilience4j and Sentinel. So in today's video, we are going to look into the Resilience4j circuit breaker. So like I discussed earlier, so these are the different states that we have. Closed state, which means everything is working normal, all the requests are going through. So once the failures go above the threshold, it goes into an open state. And during the open state, after a certain wait duration, it would let some of the requests go through, which is we call the half open state. And depending on the outcome, it will either go to closed state or it would go back to open stating. Now, what are some of the other solutions to prevent cascading failures? So one is, I think, load shedding on the server itself. Like on server B itself, if it can identify that service B can identify that okay, it is under load and it can start to fail fast, then even in that case, we will not see these slow calls from service A. I've discussed in another video about load shedding. I'll add a link to that video in the description. You can look into that. And the other way is, instead of synchronous API calls like service A calling service B and waiting on for a response, if your design permits, you can go with asynchronous calls. So what do you mean by this? Like you would set up a queue. Service A would push a message into a queue and service B would read from the queue. So in this way, even if service B goes down, what would happen is the queue messages would start building up in the queue and they will not be processed, but service A as such will not be affected. So asynchronous system is also asynchronous calls is also a good alternative, but it depends on the use case whether you can go with asynchronous calls or not. So these are the other alternatives to circuit breaking. Now let's take a simple example on how to implement circuit breaker, right? Now in our case, we have let's call this mock server as service B. Okay, now this is exposed on it's a simple SpringBoot application. It is exposed on port 8999 and with the context path mock, and this is just for the sake of testing. I set max threads to 1. So what this means is that there's only just one thread available to serve the request. And in the test controller, once we hit this endpoint, it is sleeping for about 10 minutes. So this is to replicate our slowness in service B, right? We are trying to mimic that by sleeping the only thread that we have available. So we have just one thread, and when a request comes in, that one thread goes into a sleep state. So that means if further requests come in, they will not be able to get to this controller, right? So this is our service B. So now let's start this service B. Now what is our service A? Now let's go to our service A here. So our service A is another simple Spring Boot application which is available on port 8888, and the context path is /test here, right? And it is trying to access service B at this path. In our test controller, what we are really doing is when you call this hello endpoint, you're making call to this REST template kind, REST client, which is in turn calling service B. So I'll talk about some of the configurations that we have in the circuit breaker here, but let's run this application and see what happens. Okay. So now I'm starting up service A. So service A is up, service B is up. Now let's try to access service A. We are trying to hit service A here, which internally calls service B. So as you can see, when I hit it, it is waiting for a response, right? That is because your service B, as I discussed, it is blocking that single thread that we have for 10 minutes. And now in the service A, if you go to the REST client, I set the connection timeout and read timeout to 5 seconds. So that is the reason your request has failed after waiting for about 5 seconds. So now let's send another request. Even this failed after 5 seconds. Let's send another one. So we are waiting for the circuit breaker to kick in here. This failed with 5 seconds again. This failed too with 5 seconds timeout. This too failed with 5 seconds. Now see, this responded back within 39 milliseconds because it failed fast. So what has happened here is circuit breaker has kicked in. So when circuit breaker has kicked in, it went into open state and the request immediately failed. The request did not go through to service B, rather service A itself failed the request because it identified that there is some problem with service B and did not let the request go through. Now this is the half open state. It is sending one of the requests to go through to service B to check if it is working, but it again failed with 5 seconds, right? So this is the half open state. So that is the reason you're seeing some of the requests going through to service B. Now again it failed fast. Now from half open state it again went to open state. So this is how a circuit breaker works. Now let's look into the circuit breaker. How is it designed with Resilience 4J? So as you can see, there is the circuit breaker factory. We are creating the circuit breaker class here. The configurations, you can see the failure rate threshold is 50. That means out of 100, if you're sending 100 requests, if 50 of them fail, that means circuit breaker should kick in. So how long should it wait in the open state? So it would be in open state for about 5 seconds. So in those 5 seconds, it would after an open state, it would go to half open state and it would allow like 2 calls to go through. So if you're sending like 10 calls to service A, it would allow only 2 calls to go to service B. Rest of the 8 calls will fail immediately. And this is the type. So we have like various types available. The sliding window type, the one that we are using is count based. I think the other alternative that we have is time based, which I'll not be discussing in this video, but I'll share you the link for the documentation. You can look into it. The sliding window size is 5. That means out of 5 requests, if 50% of the requests fail, circuit will go into an open state for a duration of 5 seconds, and after that it would go into a half open state where it would allow 2 calls to go through, and if they succeed, the circuit will be closed, and if they don't succeed, it will continue to be in the open state. So you create this circuit breaker bean here, and in your REST client, when you're actually making a call, so this is your REST client, and let's go to a controller here. So you can see you're saying circuit breaker dot supplier. You say execute supplier, and this is the actual method which is making call to service B. So you pass this method to the as a supplier in here. So this is how the circuit breaker knows what are all the calls going through to service B. Oh, I'm sorry, I think I forgot one of the important ones here. So it is recording the exceptions here. So if there is a service exception, this is how it knows that it is a failure. In your REST client, when you receive some sort of an exception from service B, you're throwing a runtime exception. So this is how circuit breaker knows that the call to service B has failed. It will mark it as a failure. Makes sense? So yeah, this is how a circuit breaker works. This is a small example. So I'll be uploading this code to GitHub. I'll share the links to the repo in the description as well. Yeah, I hope you enjoyed the video. So let me know if you have any questions. So you can post them in the comments, and I'll try my best to answer your questions. So that's all we have in this video. Thank you very much. Please do share and subscribe. Thank you.